Hi friends, welcome back to my channel. In this video I will explain about classification of states and chains in stochastic process. In the previous video I will explain what are the basic terminologies in stochastic process and what are the classifications of stochastic process with examples and simple definition of Markov chain with example. Now we can see in this video I will mainly explain what is irreducible chain, what is recurrent, what is mean recurrent time, what is aperiodic, what is homogeneous, how we can find stationary distributions with examples. Okay, first we can see what is irreducible. In irreducible coming on comes under the case of communication. For example, I have I state and j state. There is communication between I and j also. Then we say that irreducible. If chain have from I to j only, then we can from j to I not possible. That time we says that reducible chain. That time we says that we can see all examples also. Now I am just telling what is what. Now we can see recurrent, persistent, transient. These all are some different kind of things we can discuss. Aperiodic also, homogeneous, stationary distribution also we can find with simple examples also we can see. This is some definition. Homogeneous, irreducible, aperiodic. Homogeneous, how we can say that a given chain is homogeneous or irreducible. Aperiodic means limiting state of probabilities. Probability of j equal to limit k tends to infinity. Probability of j exists and are independent of the probability of 0, 0, 1. We can see some examples also. This is definition. This is also see. If all states of the chain are recurrent and their mean recurrent time is finite, then we say that PGs are stationary probability distribution, and we can be demonstrated by solving this type of equations. This is a formula for stationary distribution. If when you solve examples, okay, that time you can understand simply. Okay, this is definition. This is formula for mean recurrent time of SJ classes. When independence, then how we can find probabilities also. See, this is example. Consider a communication system which transmits the digits only 0 and 1. So we have 0 and 1. Now we can construct trans when we construct matrix, sorry, see, through the several stages. At each stage the probability that the same digit will be received by the next stage as transformed is 0.75. What is the probability that zeros is considered at the first stage is received as zeros by the fifth stage? See, this is my transition mark. This is the same digit here 0, 0, so 0.75. Remaining is 0.25. Here 1, here 1. So here I got 0.75, here I got 0.25, 0.25. See, by observing question, see, now we can calculate p square p power 4 also. First observe question. At each stage the probability that the same digit will be received by the next stage as transmitted is 0.75. What is the probability that a 0 that is entered at the first stage received by 0 by the fifth stage? See, for this we need 4 times probability. When you calculate 4 times probability, see, therefore the probability that 0 will be transmitted throughout the 4 stages as 0 is, it is clear that Markov chain is irreducible. See, how we can say that irreducible and aperiodic means, when you find graph then you can easily understand. When you find a graph, see, here 0 to 0 is 0.75 and 0 to 1 is 0.25, 0.25, and 1 to 0 is 0.25, and 1 to 1 is 0.2. Here all classes are communicating, so it is irreducible chain. Irreducible chain. Okay, how we can say aperiodic means if probability of II is greater than 0, then we says that it is aperiodic. See, aperiodic, and it is irreducible. So for finding 0 0, here we got 5 3 1 2 5. Now we can find same question for what we say. See, stationary distribution. We have the equation. This is general equation. 5 naught plus 5 1 equal to 1. When I multiply for 5 naught, I got this equation. For 5 1, I got this equation. When you solve these two equations, then you can substitute this. Finally, you got stationary distribution for given Markov chain. This is a stationary distribution. You can see one more example also. Then you can easily understand. This is for convergence rapidity. So pi is stationary. These things we don't need. Now you can see, when you understand this example clearly, you can understand. See, state transition diagram of discrete time Markov of a CPU. This is my tree diagram. Transition graph. Now we can prepare transition probability matrix. How we can prepare probability matrix means, we here I have 0 class, 1 2 3. Here 0 to 0 probability is 0.99. See, 0 to 0 point probability is 0.99, and 0 to 1 is 0.11. So here is enough. There is no, because here we got 1 also. Same thing you can understand for 1. From 1 to 1, probability is 0.92. Which is here 0.92. Then here 1 to 0 is 0.02. 0.02. Like this, you can prepare transition probability matrix. Then we need to find station distribution. For finding station distribution, we can take it as it is as pi naught, it is pi 1, it is pi 2, and pi 3. Pi. When you multiply both matrices, you get 4 equations. One final equation is total pi 1, pi naught, pi 1, pi 2, pi 3 equal to 1. Then you find pi naught, pi 1, pi 2, pi 3 values. Then you get stationary distribution. See, here I am taking p naught in place of pi's. First we have here p naught, here p1. See, 0.99 p naught, 0.02 p1. Okay, see, for this example for p1 p2, this is final. This is final equation. When you solve all these 4 equations, then substitute all values in final equation, then you get some values for p0, p1, and p2, p3. When you add it all 4 probabilities, then you got 1. This is stationary distribution. Now we can see how communication between transient and recurrent, persistent, not null, all things now we can see. See, this is a general definition for communication classes. State I and J are communicated if each is accessible from each other. There is 2 states are there accessible from 1 to 1 and this one to this one, like this. Transient means if I am finding FII probabilities, FII probabilities, it is not equal to 1. For persistent or recurrent, it have equal to 1. For persistent or recurrent, it has FII equal to 1. This is definition. On the process of state I, there is a positive probability that it will never return to the state I. Then we say that it is transient state. How this you can understand by example. Now we can see, this is brief classification states that we have recurrent state and transient state. Recurrent also known as persistent also. Persistent also. Recurrent have periodic, aperiodic also there. Periodic, here we got observing stage. When our Markov chain is recurrent, then we get observing. Here in transient case, we don't get observer case. Now we can see simple example. See, this is my graph. See here two stages, 0 and 1. 0 0 probability is 1 by 4. 0 0 probability is 1 by 4. And 0 1 probability is 3 by 4. 0 1 probability is 3 by 4. 1 0 1 0 probability is 1 by 2. 1 by 1 probability is 1 by 2. Now how we can say this chain is recurrent or persistent or transient or observing all things? Now we can see here communication class is 0 to 1. Here I am taking 0 and 1. This is clear that it is irreducible because communication is possible for all classes. 0 is possible and 1 is possible. This is also correct. Irreducible and communication. Now we can find periodic. How we can find periodic? GCD. Generally we can take it as GCD of highest common factor, then we get some value. Finally there is one shortcut also there. If pii value is greater than 0, then we say that it is aperiodic. See, this is 1 by 2 is greater than 0, 1 by 4 is greater than 0, so it is aperiodic also. Now we can check for recurrent. How we can check recurrent means, see, for my chain started from 0 to 1 and communication is possible for 1 to 0 also, so it is recurrent. Okay, now I am going to 1. From 1 to 0 is going and 0 to 1 is also coming, so it is recurrent. There is problematically you can solve also by applying formulas, but when you formulate graph you can easily understand. We don't need all calculations also. By assuming graph we can say it is persistent or transient. Now we can, for how we can apply formula. For applying formula I am taking F11. F11 means how many steps I will come for 0 stage in one step. F11 one step. For one step I have 1 by 4 probability. Now I can check for 2 steps. In 2 steps I have, I go to 0 to 1 and 1 to 0. So 3 by 2 into 1 by 2 equal to 3 by 4. Now when I can checking for 3 steps, that time here I got one looping. Here in this loop I got geometric series. Geometric series, when you solve this all series, finally you can summation it, you can get one value 1. Okay, this is simple calculation, but we don't need all calculation also. By assuming we can, by transition graph we can say that it is recurrent or persistent, all things. Now we can see another example. See, this is my another example. Here we have 2 states. One, oh sorry, I am taking 1 or anything, you can take 0 or 1. From 0 to 0 is 1 probability, and 0 1 to 0, 1 to 0 is 1 by 4, and 1 to 1 is 3 by 4. See, by observing we can say that it is reducible, not irreducible, because communication between both chains is not there. See, from 0 to 1 not possible to go from 0 to 1, so 1 to 0 possible, 0 to 1 is not possible, so it is communication is 0 is different, 1 is different, so this is correct. Now we can check for transient or persistent. For checking transient or persistent, see, observe, from you can take one class. Here 1 is going to 0, but there is no return to this class, so it is transient. So transient. If you take 0 class, 0 is same here, 0, there is no any communication problem, so it is recurrent. Recurrent or persistent. See, transient is 1 and recurrent is 0. Recurrent is 0. How we can check aperiodic means a probability of 1 greater than 0, here 2 also greater than 0, so it is aperiodic. Now we can check for observing state. Observing state means this is reducible, so when you can take 0 class, no possibility for going from 0 to 1, so it is observing state. It is observing state. Now we can see another examples also. See, this is another example. We have 0 class and 1 class and 2 class and third class. Now we can format a graph. From 0 to 1 is 0.5. 0 to 1 probability is 0.5. 0 to 1 probability is 0.5. From 0 to 4, 0 to 3, sorry, 0 to 3 probability is 0.5. So 0 class is enough. Now we can check for go to 1. Class 1 to 0 is 0.25. Arrow marks are important. And 1 to 2, here 1 to 2 is 0.75. 1 to 2 is 0.75. 0.75. And 2 to 1, 2 to 1, 2 to 1 is 0.3, and 2 to 3 is 0.7. Okay, then 3 to 0 is 0.2, 3 to 2, 3 to 2 is 0.8. Okay, now we can check is reducible or reducible. First we can say 0 chain. From 0 chain communication is possible or not. From 0 to 1 is going, and 1 to 2 is going, 2 to 3 is also coming, 3 to 0 is, so 0 is it is irreducible. For checking 1 also, 1 to 0 possible, 0 to 3 possible, 3 to 2 possible, 2 to 1 possible, so it is also possible. Now we can check for class 2, 2 to 1, 1 to 0, 0 to 3, this is also possible. You can check 3, all are possible, so it is irreducible. It is irreducible. Now we can check for transient or persistent. For checking transient and persistent, first we can check transient and persistent. Transient and persistent. Okay, for checking transient and persistent, now I am checking 0 class. From 0 to 1 is going, and 1 to 2, 2 to 3, 3 to 1 to 0 also communicating. Now you can say 0, 0 to 3, 3 to 0 communication is there. So 0 is persistent class. 0 class is persistent. By using the property from irreducible, one chain is persistent, then all chains are persistent. So 1, if you check 1 and 2 and 3, all are persistent. All are persistent. There is no transient and observing stage. Okay, like this type of example we can discuss more examples also in next videos. This is simple more examples from next videos. This now I discuss only simple examples. From next video onwards I will discuss more examples with more applications and lot of techniques also here. Thank you for watching. If you have any queries, you can contact me.